Hello everyone, this is Ahsanul of Kowshik from CSE department, and today I'm going to give the project demonstration of the CSC 427 family project. And the title of the project is machine learning with the spam classification of spam email. And spam email, the spam of phishing has more threat in our day-to-day life, and for that we are basically working with this project. And to topic, the dataset I have collected from the lab, and after the collecting the dataset I have applied so many models. So here at first I have the code I have uploaded the NumPy, pandas and the necessary library, and attached the collab. And after that I have uploaded the dataset, and where I have searched the dataset, and here is file with the dataset we can see the dataset. And after that we have used the labels to say that how many data points are there in total. Here is 83,448 data in total, and among them we literally can see that the dataset is not balanced. So that at first we make a copy of the dataset, and after that we have input the NTLP model so that we can process the dataset, because this is a language thing. So we have to import that thing, and with that we have first like test the dataset, like how many number of the character and if the sentence have and we have calculated each of the sentence, and we have calculated from the data set that the number of character, number of words and the number of sentences. With that we can see that we have calculated for both of the, like for the Hamon and also for the spam, where we can see that like the the sentence, the span sentence have more character and word than the have one. After that, we have the data. We have pre-processed the data of the data set, where we have see that any kind of null value or any kind of blank object are there or not. We found that there is nothing, any kind of blank. After that we have using the analytical model, we make the text, we make the sentences to token, and with the tokenize we will train the data. So this is the process of tokenize, and where we have taken, like we have tried to like take as much sample so that we can train our model for our. But for the section of the collab RAM we couldn't train all the data, so we have trained 4,000 and 4,000, in total 8,000 of data in this project, where first we have taken 4,000 and 4,000 to make it a balance and such thing. And here we have the split the data set into two parts. One is training set and another is testing set, where we maintain a ratio of 70/30. And after that we have written the model training part, where we have trained four model till now. And with the 8,000 of the dataset, where we have in first we have tried the Gaussian bias, which is basically a naive Bayes model. But in GitHub we found the Gaussian bias, and the accuracy of the naive Bayes is about 91.17% with our 8,000 data point. And where we in the confusion matrix we see that it is perform well with a precision level of 98% and with a recall value of 0.84%, where in total the test section it perform for as a actual ham and 1195, and another one the actual spam is a 93%. But after that we have tried another model, which is a logistic regression. We import the logistic regression from a cycling model, and where we have do the same process for the logistic regression also. And we have found that the logistic regression model perform better than and the naive bias, which is 96.58%, and where the precision level was this time 95%, whether the recall value was 98%, where we can see its perform actual ham is 11.8%, 1160 and 100 100 100, and after that we have tried another new model which is a decision tree. Decision tree is another model which is a very well known model for the machine learning practice as well, where I have used the decision tree model, where with that decision tree we got accuracy on this data set about 90.71%. And if you see the confusion matrix, we have got a precision level of 92 and recall of 89%. But regarding this decision tree, the other model performed better. Regarding decision tree couldn't perform well here. Also, at last we have tried the KNN model, which is also known as the neighbor model, KNA neighbor classification model, where we took neighbor as 12, and after that we here it performed not very well. The accuracy level was 84.79% with our data set, and where the recall value was 98% and the precision value was 77%. And after that here we have implemented all the accuracy value to see which one is better by a bar chart, where we can find that the logistic regression perform the highest among the all other model. And lastly we have placed all the recon value and the precision value, where we can see that the naive has the recon value highest, but he doesn't have the sorry, my bad, the right belt has the precision value highest but not the recall value on the other hand. And the KNN has a better precision value, same as logistic regression, but the decision tree has the lesser of both precision and recall value. Here we can implement among the accuracy and precision and recall value. We see night base got 0.91% accuracy and with a precision of 0.98 and a recall of 0.84. Logistic regression has accuracy of 0.96, and the precision value is 0.95, and the recall value is 0.98. Decision tree has a 0.90 accuracy and the precision is 0.92, and recall value is 0.89, and the QAnon is 0.84 accuracy with a precision of 0.77 and 0.84. This is the all the recall value and precision value and the accuracy for this particular model. But now, till now the logistic regression has performed very well throughout. That's all from my side. Thank you.